Hello, dear students. How are you all? Hope you all are doing fine. And you watched the previous 4 videos already uploaded in the Google Classroom. And this is the last video on current, electricity, and DC circuits. Today we are going to discuss circuit symbols, then we will discuss series and parallel circuit in more details. Finally, we will discuss potential divider. The first thing, that is circuit symbols. To draw circuit diagrams, we need different types of components. We need lamp, we need ammeter, voltmeter, we need wires, we need DC or AC power supply, then we need resistors, we need thermistor, we need LDR or light dependent resistor, and many more components. So if we don't use the circuit symbols, what will happen? If I draw the lamp in one way, there might be possibility that the other person for whom I am drawing the diagram, he or she might not understand it. But if we draw a common symbol for each of the components, then it's very easy to communicate, and it's much more easier to understand by the other people. That's why worldwide the researchers and scientists, they decided to follow unique symbol for each of the components we are using in the circuits. Now for O levels, we are going to have some of the components and their circuit symbols. I already gave you those symbols with labeling in the notes. Now we are going to understand them a little bit more with explanation. Look, here in the diagram I gave at the beginning switch is open, then switch is closed. When the switch is open, the circuit is off, and when the switch is closed, the circuit is on. The next one is cell, battery. You already know what is called cell or battery. Now you see, in this battery we showed 2 cells are connected one after another, and in this way many more cells can be connected together. So it's very clear to you what is the difference between cell and battery. Now diode is a component. This component is used to let the current pass in one direction only. The more about diodes structure and its function we will discuss in the introductory electronics in class 10. After diode we have LED. LED means light emitting diode. So it is one kind of diode, and you see above the symbol diode we have drew here two arrows so that we can understand that it is light emitting diode. This type of diode uh, emits light when current flows through them. Then we have AC voltage source. This is uh, one kind of power supply. We have cell, battery, they are also power supply. Now AC voltage source, this is also power supply. You will know what is AC. AC means alternating current. More details about AC voltage or AC current in our in the chapter electromagnetic induction. There we will discuss about this more details. Now you just learn the symbol. You do not need to know in details what is AC voltage source or how does it work. Later on we have here the symbol of resistor. Look, I try to give all the symbols which are similar to resistor together so that you can relate them, you can understand them, and you can remember them easily. First of all, I gave resistor, and if you give one arrow on this resistor, then it becomes variable resistor. Variable resistor means the resistance can be varied according to our needs. Sometimes we need less resistance, sometimes we need more resistance. Then this type of resistor, variable resistor, helps us to do so, and we can get the resistance according to our need. Then the next one, if you look attentively and you observe that this is also one kind of resistor, fuse. And this type of resistor, how does it work, and what is the structure of it, we will know more details in the practical electricity chapter and the next chapter. So you just know the symbol here, fuse. If you draw a complete line across the resistor, then it becomes fuse symbol. Now LDR, already in the previous video you got the idea of LDR, that is light dependent resistor. So here we got resistor, and above it we have two arrows which shows that this resistor depends on light intensity. Then we have another one, that is thermistor. So this resistor depends on the temperature. If temperature increases, then resistance decreases. This instrument also we will use in introductory electronics. That time we will know more details about it. Now we have relay. Relay is one kind of instrument or component. That one is used to run another circuit. Like one circuit is used to run another circuit, that time it is called relay circuit. You know about relay race, where more than one athletes are working together to complete the race. So this is the basic idea about relay. More details you will know in introductory electronics. Now we have bell. It's very simple, like electric bell in our school we use, that is bell, and the symbol is this one. We should remember this symbol. We have a few more symbols. Look, magnetizing coil or solenoid. You know, we learned this about solenoid and its function in magnetism. So there we got magnetizing coil where we can produce north and south pole. So the symbol of this magnetizing coil is shown here. And transformer, we have this transformer, just the symbol here. We have more detailed discussion on transformer in electromagnetic induction. There you will know details about this. Then finally we have here lamp, ammeter, voltmeter. You know about them. Ammeter is used for measuring current and voltmeter is used to measure voltage or potential difference or EMF. So that's all about circuit symbols. And these circuit symbols, mainly you have to learn the symbols. Some of them you already knew the function and their application already you are informed, you are used to. Some of them we will use later on. Our next content is series circuit. Series circuit is not very new to you. Already you have the basic idea. That is, we call a circuit a series circuit if the components are connected one after another. Now we will know how this series circuit is working, or how this series circuit is applied in various places to get the required output, or what are the characteristics of this series circuit. That one will focus now. Look, here we have series circuit. We are talking about this one. Look here, two lamps are connected one after another. That's why it is called series circuit. And what are the characteristics of the series circuit? We will try to understand from the diagram. And here I gave points, 4 points, to let you understand it easily. Look at the first point. Current remains same everywhere. We are getting only a single path for electrons to pass from positive to negative terminal. That's why current is not divided. So each of the components, they are getting the same amount of current. Both the lamps, they are getting same amount of current. Current is not divided. Every point or every part of the circuit has the same current. Now we have next point, that is voltage of source. We know that for power supply, the source voltage is called EMF, or electromotive force. So this circuit, for this circuit, we showed that for example the source voltage is 6 volt, and this source voltage 6 volt is shared into both the lamps. I showed here, as both the lamps are identical, they both have the same resistance and they will share the source EMF equally, and both of them, they are getting 3 volt and 3 volt. if there is only a single lamp, look at the diagram right side, then the single lamp will get the entire volt or entire EMF across the lamp. That's why here the voltmeter reading you will get 6 volt. Now if the voltage or the EMF is shared, then the lamp's brightness will be less. You see, for the one lamp only we are getting 6 volt, but for two lamps, they are connected in series, we are getting 3 volt 3 volt. That's why we will get less brightness for each of the component, for each of the lamp, as the total EMF is shared among the components. Now the last line you see here, third point, one switch can be used to on or off the circuit. That means in series circuit, as there is only path, only one path to pass the electricity, that's why we can use only one switch to turn on or turn off the circuit. And the last one, you see fourth point, here it's written that for series circuit we need less wiring, because it is a simple circuit. We do not have any branches, there is only a single path and a single wiring there. That's why we do not need too much wires or too much wiring to make a series circuit. So that's all about series circuit. Now parallel circuit. Parallel circuit has components connection, they have the connections together, like left side and right side, all the components they will be connected together. That is called parallel. We also say it, they are connected across each other. So from the diagram it will be more clear to us. Look, here the circuit, here we have also two lamps, two identical lamps, and these two lamps are connected in parallel. They are connected across each other, and look, left side of their connection and right side of their connection directly goes to the left side is going to positive terminal and right side is going to a negative terminal. So both the lamps are directly connected to positive and negative terminal. That's why both the lamps, they will have the same voltage. That means if the source EMF is 6 volt, then both the lamps, they will get the same voltage, that is 6 volt and 6 volt. That's why the brightness in parallel circuit, the brightness of the lamp will be normal brightness. That means if there is only single lamp, the way its light we get, the same way if they are connected in parallel, all the lamps will glow with the same brightness, because all of them are getting the same voltage as the source voltage. So this is one point about the parallel circuit. Now another one is we are getting the branches here. Here you see after the emitter symbol, I showed here current I. So this current, when it goes to the joint or the junction of two lamps, then the current is divided. The upper one we got current I1, the lower one we got current I2, and when these two current cross the lamp, they again join the left side and they are meeting together and making the current I again. So here right side I wrote here I equals I1 plus I2. That means after meeting they are getting the same current like before we got in the left side. So we can say that in parallel circuit current is divided into the branches or among the branches. These two are very vital points for parallel circuit, we have to remember. Then another thing is, for example, if one of the lamps somehow is not working, the other lamps will still work, because if even one of the lamps is not working, the circuit, the other part circuit is completed and is connected with the power supply, so it will work. So it is another speciality of parallel circuit, that is we do not need to turn on all the lamps together. If we need one lamp, we can turn on only one. If we need both, we can turn on both of them. In our house we have normally the parallel circuit. In our house we have lots of appliances, different appliances, and we do not need all of them together to run. So we need their parallel circuit, so that we can do our work according to our need. And the final point for parallel circuit is we need more wiring in parallel circuit. Like we have lots of branches here, that's why we need more wires to connect with each other, all the components. That's why we need more wiring. So I think you are clear about the characteristics of parallel circuit. We also gave here 4 characteristics and all are discussed over here. Just have a look here. I'm showing you all of them. Just have a look. Yeah. Okay. Now parallel circuit is over. We are done with circuit symbols, series circuit, parallel circuit. Now the last one, that is potential divider. Potential divider, from the name you can guess what it is. That is the potential difference we are getting, that is divided among the circuit components. That time we call it potential divider. We need this potential divider in many places. You will know it after few discussions. Let's go for this discussion, then I will give you some examples where this potential divider is used. Look, here you concentrate in the circuit drawn here. Look at the circuit. The source or the power supply is giving you 6 volt, and there are 2 resistors connected in series, they are identical resistors. Here identical means both of them they have the same resistance. So in series circuit you got this idea already that the source or power supply voltage is shared among the components in series circuit. So in potential divider we actually use series circuit to get some benefits or to use according to our needs. Look here, both R1 and R2 they are getting 3 volts each. Now for example, if we don't need them as equally, we need for in R1 we need more, R2 we need less voltage. That time what we will do, that one is given here. You see in the diagram given below, you can understand it. Look here, this diagram at the left side bottom is given 12 volt. The power supply is given 12 volt. Then we have one fixed resistor of resistance 8 ohm, and there is one motor connected across this resistor, so that this motor gets the same voltage of R1, because the motor is connected in parallel, and we know the in parallel combination all the components they have the same voltage or same potential difference. So the motor is connected to R1 parallelly, and that's why whatever the voltage R1 is getting, motor will get the same one. We have beside it R2. R2 is given 4 ohm. So we have R2, it is variable resistor. That means we can make the resistance changed according to our need. For example, now we need 4 ohm. That's why we kept the resistor in a way that it's giving us 4 ohm. Now you please look at the left side of the top diagram, top circuit diagram. I wrote here one formula, that is V1 equals R1 by R1 plus R2 into V, and the right side again I wrote V2 equals R2 by R1 plus R2 multiplied by V. These two are potential divider formula. We will now apply for the next circuit just now we discussed. So the formula is V1 equals R1 by R1 plus R2 into V. For this circuit diagram, our resistors are 8 ohm for R1. We are going to find the potential difference or voltage across R1. That's why we are saying it V1. So V1 equals 8 ohm divided by 8 ohm plus 4 ohm, that is R1 plus R2, multiplied by the source voltage, that is 12 volt. So if you calculate, V1 comes 8 volt. So from this diagram we understand, if R1 is getting 8 volt, then R2 will get the other rest part, that is 12 minus 8, that is 4 volt. So R1 will get 8 volt and R2 will get 4 volt. That means the resistor R1 is getting double the voltage than R2. I think it's clear to you. Now we are going for other example where we are getting different values for R1 and R2. Like for R1, as it is fixed resistor, we have still it is 8 ohm, but for R2, as this is variable resistor, we can change it. So according to our need, we are changing it, and it is now R2 equals 8 ohm. Again we are applying the same formula, V1 equals 8 ohm by 8 ohm plus 8 ohm into 12 volt. So here V1 comes 6 volt, and this is amazing that according to our need we can get the voltage. Previously we got 8 volt across the motor, now we are getting 6 volt across the motor. So it's very clear to you that if one motor is getting 8 volt, that motor will run faster and it is more efficient, and if the motor is getting less voltage, 6 volt, then it will run less than before. So here the motor will be slower and it is less efficient. For this one we can bring one daily life example, like today even in the morning we had to slow down the ceiling fan, because during the morning the environment, the weather, the surroundings a little bit colder. That's why we had to use the regulator of the fan. I think every one of you you have the regulator with the fan, so that you can increase or decrease the speed of the fan. This is one example of potential divider. We are using the basic idea of potential divider in this regulator. Here when we are giving more voltage across the fan, then the fan is moving faster. When we are giving less voltage across the fan, then the fan is moving slowly. So with this example it's clear to you. Even in blending machine, you know, we have there 1, 2, 3, so that we can increase the speed of the motor or decrease the speed of the motor. In many other places we are using this regulator or potential divider. I think now you are very clear about potential divider. So today we are done with the current, electricity and DC circuit, this topic completely, and by this video we are done with 2 topics of Cambridge syllabus. One is current, electricity, another one is DC circuits. If you go through the syllabus, you can check that in our videos we try to cover all the learning outcomes, and beside I try to bring some examples and the numericals and the formulas, the circuit diagrams, to make it more understandable to you, so that you can easily take the exams and you can be prepared well for O-level exams. In my notes and in my videos, I try to bring all the ideas from the past paper questions, so that you feel very comfortable when you are solving the past paper questions. So thank you so much for listening, and hope you enjoyed the video. It is helping you to learn with ease, and please pass your life with safety. Stay at home. Best of luck. May God bless you all. Bye.